Assalamualaikum and a very good day to all of you, especially our lecturer Dr. Noor Amani Filzah binti Muhammad Kamil. My name is Azmi Ruzaidi Muhammad Ruslan from Section 3, Group 2, and today we are going to present our project about slope of surfaces. But before that, I will introduce you to our group members. The first one is Anis Amirah binti Ani Riza. Her life's motto is, if you can't be nice, be quiet. Second one, Nur Azian Shafiqah binti Muhammad Yahya, and her life's motto is, do not bother others. Our third group member is Siti Nur Aisha binti Muhammad Sofri, and her life's motto is, be a person who is beneficial to others. Our fourth one Muhammad Azim Daniel bin Alwi, and his life motto is, develop yourself to develop others. After that, the fifth one is me, Azmi Ruzaidi bin Ahmad Ruslan, and my life's motto is, yesterday I was clever and wanted to change the world, but today I am wise and want to change myself. And our last member is Muhammad Rashid bin Rosli, and his life motto is, never give up. And now I will tell you what is slope of surfaces. But before that, what is a slope? Slope is a measurement for steepness of the ground surface. The slope is affected by the steepness of the surface. The steeper the surface, the greater the slope. Slope is measured by calculating the tangent of the surface. The tangent is calculated by dividing the vertical change in elevation by the horizontal distance. Now, what is slope of surfaces? Slope of surfaces is calculated and obtained by differentiating function of two variables. For function with single variables, using differentiation will obtain the slope of a certain curve, different with function of two variables. Slope of surface can be evaluated in two directions, x, or known as fx, and y direction, which is known as fy. Now, let's go into our problem statement. Our problem statements. The engineer figured out that the bridge needs to achieve a minimum level of inclination for the vehicle to have a safe speed limit that can be achieved going up and down the bridge for a gentle, non-weight intensive load. Given that the paraboloid bridge at Paraboloid Hill with maximum height of 16 meter, that is 6 meter wide, at the height of 8 meters.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashid bin Rosli. My metric number is 190073. I would like to present about the problem statement Villa table. Okay, for the situation given, the engineer figured out that the bridge needs to achieve a minimum level of inclination for the vehicle to have a safe speed limit that can be achieved going up and down the bridge for a gentle, non-weight intensive load. Given that the paraboloid bridge at Paraboloid Hill with maximum height of 16 meter, that is 6 meter wide at the height of 8 meter. The first fact is bridge with paraboloid curve at Paraboloid Hill. The ideas, we need the paraboloid equation for this problem. What we learn is how to determine the equation. The action that we take is we get the equation fxy equal to negative 8 over 9 x square minus y square plus 16 from the height of paraboloid bridge, which is 8 meter and 6 meter wide. We use equation for paraboloid bridge y equal to negative a times x minus h square plus k. The second fact is bridge has a slope of surface when in contact with the ground surface. The generated idea is we need to find the slope at certain point for x direction and y direction. What we learn is how to determine the specific point. The action, we must calculate from the architect design by using point 016 as a vertex, which is a turning point, and point 38, which is any point on the paraboloid curve. We'll get from the width of bridge from the center, which is 3 meter, and height of bridge, which is 8 meter. Then we can find a dilation factor to get the equation of paraboloid bridge. Last but not least is illustration of the surface in the first order and the slope of the bridge. The ideas we illustrate the surface in the first octane and its slope. What we learn is how to determine the first octane and its slopes. The action that we take is we use the equation of parabolic bridge, which is y equal to negative 8/9 x squared plus 16, and using the 0.38, we apply the formula of partial derivative to find the slope of the surface in the x direction and y direction. That's all. Thank you.
Hello and Assalamualaikum. My name is Nur Azza Syafiqah binti Muhammad Yahya. My metric number is AF190107. Okay, so I will talk about limitation in slope of surface, variable and some assumption in this topic. In our problem statement or situation state that the graph of a quadratic equation in two variable y equal to ax power of 2 plus bx plus c is called a parabola. The following graph are two typical parabola. Their x-intercept are marked by red dots and their y-intercept are marked by a pink dot, while the vertex of each parabola is marked by a green dot. To graph a parabola, we need to find its intercept, vertex and which way it opens. In mathematics, we assume if a greater than 0, which is positive number, then the parabola opens upward. If a less than 0, which is negative number, then the parabola opens downward. For our cases, we get the parabolic equation of the bridge, which is fxy equal to negative 8/9 x power of 2 minus y power of 2 plus 16, which is the parabolic bridge is in downward shape. Based on the topic slope of surface, we should know that there is a limitation in every calculation we make. First, we state that our paraboloid bridge is erected on a paraboloid hill. When we are talking about the surface of paraboloid hill in real life hill, we cannot direct use the equation of the paraboloid hill to get calculation to build a paraboloid bridge. A parabola is two-dimensional, somewhat U-shaped figure. This curve can be described as a locus of point where every point on the curve is at equal distance from the focus and the directrix. So the figure given explain about the location of axis of symmetry, focus point, vertex point and directrix. And this is a U-shaped parabola which is A is larger than 0. So, to conclude what is the limitation in slope of surface topic, we cannot call any U-shaped curve as a parabola. It is essential that every point on this curve can be at equal distance from the focus and directrix. Therefore, if we want to apply this parabolic equation for paraboloid hill in real life to get the slope of surface, the probability of obtaining an inaccurate value is high because the surface of the parabolic hill is not exactly U-shaped, and this will cause to get the higher probability of an equal distance point on the curve.
Assalamualaikum and hi everyone. My name is Siti Nurasha binti Muhammad Sofi. Today I will explain about methodology and calculation. So first, in methodology, the method that we propose to use as the calculation to solve the problem of slope of surface is by derivative of the equation. In right of view, this is the shape of parabola. As we can see, a parabola has no slope. We can try by sketch a straight line pass through to the line shape of parabola. We found that there is no slope. Same goes to other position. We make a line at the closer to the turning point. It also no slope. However, finding the instantaneous rate of change is very possible. The derivative of a function at a point can be defined as the instantaneous rate of change or as the slope of the tangent of a function at a point is the slope of the function. This process of finding the derivative of a function is called differentiation. For the function of two variables, we deal with line. The slope of the surface can be evaluated in two directions, which are in x and y direction. For fx, same as slope of the surface in the x direction, while fy equals to slope of the surface in the y direction. This is shown that the general equation of parabolic y equals to negative a times x minus h power of 2 plus k. When we have two variables in the equation, we just change y equals to f respect to x and y, where a is direction factor, h is height of the parabolic shape, and k is y of parabolic shape. Note that the turning point of the paraboloid shape is called as vertex point, hk. So, for calculation, The equation is, the engineer figured out that the bridge needs to achieve a minimum level of inclination for the vehicle to have a safe speed limit that can be achieved going up and down the bridge for a gentle, non-wear intensive load, given that the paraboloid bridge at paraboloid hill with maximum height of 60 meter, that is 6 meter wide, and the height of 8 meter. So at first, we need to find the equation of the paraboloid from value of vertex. This figure shows that the summary of the equation. So, as we can see, the value of vertex is 0, 16. The height of the bridge is 16 meter, and the width of the bridge is 6 meter. And we also have 2 points, which is point A and point B. First, substitute vertex point 0, 16 into the parabolic equation, and then we get y equals to negative a times x minus 0 power of 2 plus 16. To find value of a, we need to choose any point from the figure, either a or b. So, we choose point b, and substitute the point into the equation that we found just now. And then we get a equals to 8 over 9. Then the equation of the parabolic bridge is y equals to negative x over 9 times x squared plus 16. Next, second step, find the slope of the surface in the x direction and y direction. For slope in x direction, we have to using partial derivative for fx, and then we get fx equals to negative 16 over 9 times x. And then we just substitute point that we have used just now to the fx equation, and then we get fx equals to negative 16 over 3. In x direction, the slope at the point 3, 8 is negative 16 over 3. For slope in y direction, also need to using partial derivative for fy. Then we get fy equals to negative 1. Substitute point 3, 8 into the fy equation, and then we get fy equals to negative 1. Finally, in y direction, the slope at the point 3, 8 is negative 1. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anis Amira binti Aniriza. My metric number is AF190048. Today I would like to explain about our result from our calculation. To get the result, we need to illustrate the slope of surface in the first octant. So, let z equal to negative 8 over 9 x squared minus y plus 16. As we know, on the xy plane, z equal to 0. So, we have 8 over 9 x squared plus y equal to 16. To get the y value, we need to substitute x equal to 0. So, we get y equal to 16. To get the x value, we need to substitute y equal to 0. So, we get x equal to plus minus 3 square root 2. Surface in the first octant. Okay, this is the look of our bridge when we sketch the surface in the first octant. On the z-axis, we get 16 from the maximum height of parabolic hill. And then the x-axis, we get 3 square root 2 plus minus. We get from the previous calculation, same as on the y-axis, which is 16. Okay, next, this is the look how slope in x and y direction. On the x direction, we get negative 16 over 3 slope in the x direction. In the y direction, we get negative 1. On the x direction, the slope is parallel to the x-axis, while in the y direction, the slope is parallel in the y-axis. From the calculation, we know that slope in x direction is more safer than the y direction, because in the x direction we get negative 1, which is more smaller, so that the slope is not too steep. Okay, this is the look how our bridge look like. It is safer to vehicle go through the bridge.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim, metric number FY90085. So today I would like to present about the last section of our report, which is the conclusion. Okay, for the conclusion, application of slope equation was widely used in calculating slope in bridge, hills, and others. Our equation has been derived based on the parabolic hill height and width, which is 8 meter and 6 meter respectively. Using the information, we use the points 0, 16 as a vertex and point 3, 8 which we obtain from the height and the center of the bridge. Y, we calculate the direction factor A. So after getting the A, we complete the equation that we need. Using the equation, we calculate slope both in x and y direction using the partial derivative methods. And after that, we illustrated the structure of the bridge in the first octane. So based on the illustration, from the observation, we can conclude that the slope in x direction is much safer compared to the y direction, because the value of x is smaller than y, which is negative 16/3, equivalent to negative 5.333 and negative 1 respectively. So we can conclude that the smaller the number or the value of the slope, so the much safer that we can get. So in this case, we can conclude that the x direction is much safer because the value of the slope is smaller than y. So that's all from me. Thank you.